So today I'm going to show you how to build this logger and what I collected with it when we went to the drag strip as a part of the course. Um, First off, I'm going to start with the build process, what parts I used, what parts we were required to buy but didn't work for me, and all of that stuff. First, I bought a 5-inch LCD display that's actually touchscreen, and I also have a GPS USB module and an OBD2 to USB module, as you can see here. I ordered a SenseHat, but the SenseHat would make the Pi freeze on startup, so I kind of thought that would be something I could mess with if I ever got it to work. But there were build instructions supplied on the Canvas page for this course that I used to build this, and I can go ahead and pull those up here. So these are the instructions on the Canvas website. It basically walks you through how to set up the Raspberry Pi from the box, and what repositories from GitHub you should use to download these logging files. Basically, it walks you through how to give yourself permissions to everything, how to see what things your devices are outputting. So this will show you your GPS data output, and then one of the ones before it I think will show you your OBD output and whether or not it's actually reading the OBD port from your car. And after that, this walks you through how you should type in the command to start logging, and this obviously will change based on which file you're using. So I used obdlog.py for logging my OBD data. I tried using the this obdlog17.py, and it would never get off of idling, so I chose to use this obdlog.py. This is my logger, and in this obd.py, when I went to the track, the program that I ran was this obdlog.py, and basically I ran this because the GPS would not record data. When I went into the command module and went to this pyobd.py folder and typed gpsmon, it would give me this screen, no problem. And it would tell me longitude and latitude because there was GPS signal. But for some reason, when I tried to run any of the GPS loggers, it wouldn't find the GPS. So I'm not sure exactly what happened there, but I ran obdlog.py because that was the only program that would allow me to log data based on my GPS's problems. The obdlog.py program collected throttle, RPM, load, speed in miles per hour, fuel status, and time. And that was saved to this log file, and all of these logs are from that program. The logger, this system in whole, was held by a passenger, and they
would type in the commands for running that program, and right as I got up to the line, I would tell them to hit enter and start logging, and that would that would start the logging in enough time to where when we took off down the drag strip, it had recorded data of me idling before taking off. So there was a clear line of when the logging started and when the car actually started doing something on the drag strip. And then once we got to the end of the drag strip, we would hit Control C, and that would stop the logging in the program, and it would save to this log file. The test plan was to change the car, and at the end we added a passenger to see how much that would change the load or the speed. And we also changed cars in order to determine what the performance difference was between a 2000 Camry and a 2017 Camry, because there's 17 years of difference, and we recognized that their engines weren't entirely different. They were pretty similar, so we thought that that would be a good test to see what the difference was.
So here we have two data sets, both from the older 2000 Camry. And as you can see, we have RPM and miles per hour up top, and then load and throttle on the bottom. As you can see, the max value is only 72%, which means I wasn't completely flooring it, and mostly because I didn't want to break the car. I don't know how sturdy it is after 17 plus years of being in use. So as you can see, my max is only 55 miles an hour compared to the second run with this same car. My max was 58 miles an hour, and I can only really attribute that to maybe the car warming up. There's only a real difference in speed between these two. The load and throttle are pretty similar, and the max RPM here is actually higher, so that's probably got something to do with the max speed. Um, After that, we have the runs from the other car. This one the RPM starts pretty high, and I'm guessing that's because the passenger didn't start logging until around the time when we launched from the line. Um, this is a better data set. We started much earlier with logging. But basically, this run was with an extra passenger in the car, and you can see the max speed is decreased to that of the first run with the newer car. Um, and because these because the two cars are fairly similar, the speeds weren't drastically different, but you can notice the difference. But also, if you compare this throttle and RPM, if you compare the throttle and RPM from this graph to that of one of the other two, the gearing actually seems to be fairly similar between the two. The load and the RPM, or the load and the throttle between these two is actually fairly similar, and the RPM curve, the gearing is fairly similar between the two cars, which tells you these cars aren't too different despite there being 17 years between them. Basically, you can attribute the differences between these two vehicles to the fact that since the newer one has more advanced technology in it, it can monitor the condition of the car better and understand how to change inputs to the engine in order to get it to go faster. That's why you see these differences in speed. If I could change anything that I would have done to collect more data or different data, I would have probably messed around with that GPS, the OBD GPS log file, in order to try to get the GPS to work so we could compare the OBD speed data to that of the GPS and see if it's accurate or if the GPS is um, telling me a speed that's more accurate than OBD, or if the logging rate is too slow on OBD, you can use the GPS as a substitute for this speed so that you get a more accurate second to second update of what the speed is. In conclusion, I would say that the newer model car is faster basically due to having more advanced technology and monitoring systems and a better tune on the engine. And my assumption that the newer model year car would be better because of that is validated because both runs with that car were faster than the runs of the with the previous car. And that pretty much does it for this project. We figured out that a 2000 Camry is slower than a 2017 Camry, even though it's lighter than the 2017, and that's mostly due to technology. I hope you enjoyed, and that's been my project. Thanks.